Today is 11/21/17. Up to now, we've been talking about things that are launched horizontally. So they only have initial velocity on the x-axis. They have no initial y velocity. But what we're going to start to do now, just because we're evil and we can, is launch things at an angle. Which means they have an initial velocity on the y and an initial velocity on the x. This does complicate matters somewhat, honestly. But it also makes for lots of possibilities. One of those possibilities is building ping pong launchers. And we do the ping pong launchers based on the YSU Physics Olympics rules. So we're going to just talk about this conceptually. I'm not going to introduce the math yet today. But I want to introduce the concepts. And I'm going to post the ping pong launcher assignment and rubric today. You can look over it, you can start thinking about it, start getting your creative juices flowing, and I think we might have to do one person per, just such a pain in the chuckus, but I think, well, anyway, we'll cross that bridge when we get there. I'll post the assignment so you can start thinking about constructing your launcher. The launchers won't be due for a little while, but I want you to start thinking about it. You can start experimenting with flinging things, flipping things, hurling things. You can build a trebuchet, you can build a catapult. We'll talk more about that. Yeah, I know. Trebuchets are cool. We haven't had a trebuchet built in years. Anyway, here's the big thing that honestly was a conceptual miracle to me. And I want to do this before we talk about any of the math with these problems, before we do a sample problem. Because it's so obvious and so intuitive, and yet when you just go face down into the math, I think it's not always obvious. You know how we used time as a bridge in all those horizontal projectile motion problems? Okay, here's the amazing thing, and I'm going to draw a little parabola. For every moment that this thing is traveling, every single moment on its little flight path, it has an x position, it has a y position. That's really obvious. It has an x position, it has a y position, it has an x position, it has a y position, blah, 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 blah. For every moment on its little flight path, it has a vy, it has a vx, it has a vy, it has a vx, it has a vy, it has a vx, it has a vy. I should have really shrunk that line. It has a vx. At the very top of flight, what's vy? 0. Just like when you throw it straight up and let it fall back to Earth, there's a moment at the top of this flight where vy goes to 0. And it still has a vx, and it still has a vx, and now it has a vy, and it still has a vx, and it has a vy, and it has a vx, and it has, you get the picture here. By using time as the bridge, you can solve for any other quantity on this whole flight of, on this whole, gosh, I cannot speak today. On this whole little trajectory. We'll go with that. I've been struggling for words all day. It's kind of amazing, and it's really obvious, and it's really intuitive, but I think just presenting it very plainly helps, because it took me several years of teaching physics before I went, oh, God, that's what we're doing. Well, duh. So I just wanted to say it plainly. Now, with that, we're going to watch a really stupid video about hurling objects. Embrace your inner 12-year-old redneck, because that's really the only way to enjoy this video. No.